And we are live. Hello. Welcome, everybody. Anybody who is with us, anybody who will be joining us after. Hello, Animal Play Park. How you doing? It's my pleasure to host all of you here. And we're gonna have some fun today with Universe Sandbox, where we can run simulations, where we can see different outcomes when celestial bodies meet, or when we replace the sun with a black hole. So without any further ado, let's get started. So have you ever wondered what would happen if the moon suddenly crashed into Earth? Or what if we dropped a black hole into our solar system just to see what unfolds? Well, tonight we are not wondering, we are doing it. Welcome to live Cosmic Chaos, where we're throwing out the rules of space and replacing them with curiosity, chaos, and a whole lot of fireballs. I'm Zan, this is Spaceopedia, and for the next hour we are diving headfirst into one of the most powerful simulation tools out there, Universe Sandbox. It's not just about blowing up things, well, mostly it is about blowing up things, but it's also about asking what if. What if we made Jupiter a star? What if Earth had two suns? And what if we tried to terraform Mars by slamming comets into it? Now, if you are new here, this isn't just a game. Universe Sandbox is a physics-based simulator that models real gravity, mass, temperature, and motion. So what will we see tonight? It's rooted in actual science with just enough madness to keep things interesting. And let's be honest, space isn't always calm and quiet. The universe loves chaos. Galaxies collide, stars go supernova, moons tear themselves apart. What we're doing here tonight isn't just fun, it's a reflection of the violent, unpredictable, inspiring nature of the cosmos. So first, we'll crash the moon into Earth and track exactly what happens, the heat, the debris, the aftermath. Then we'll mess with Jupiter. Can we make it ignite like a second sun? After that, black hole will replace our sun, and we'll see what happens to our solar system. And then any wild ideas that you guys might have, please drop them in the chat and we'll see what we can do. So I've got the simulation here ready. Let me just start it for you guys. And we'll see where it's gonna take us. Let's speed things up. And let's see what happens to the planet. Look at that fireball. Incredible. Whole planet is engulfed in debris, molten rock. Just look at that explosion. Absolutely incredible. The average temperature is almost 1300 Celsius. That is so high, it can literally melt rock. So I'm surprised the Earth hasn't melted yet, but let's speed things up. Loads of plasma and debris just flying around. The Earth is just getting hotter and hotter. 2500 Celsius. Maximum temperature is 6000 Celsius. Holy crap. That is absolutely crazy. Let's speed things up even more. So now, this is 3 months after the impact. Huge cloud of debris. And the Earth's temperature has dropped drastically. It dropped from, let me slow things down. It's dropped from maximum temperature 6,000 Celsius to 336 degrees Celsius. It's impossible to imagine this scale. It is impossible. That's why we've got this fantastic tool that can represent and present us with possible scenario. So let's zoom in on the Earth. The Earth looks a lot different than what we are used to. A lot different. Let's speed things up again. Let the smoke clear out. Okay, so we can see the oceans have engulfed at least half of the planet. You can't really make out which continent is which. I think that's South America right here, but I'm not 100% sure. This used to be Africa, now it has a ginormous sea midland. Europe is devastated. We can see Italy. We can see Great Britain. And there is a big landmass that has just uncovered near Britain as well. Because as soon as the moon hit the planet, it must have shifted all the oceans. So you can only imagine the catastrophe that would happen on the planet if our moon was ever to come down. How long was that since it impact? 6.28 years. So not that long. In a cosmic scale, this is just a blink of an eye. 6 years is nothing. But let's speed things up a little bit more. So the debris cloud is still around the planet, lingering. We zoom in, we've got another ice age, as you can guys see. Minimum temperature minus 227 degrees Celsius. That is cold. That is very cold. Now all the oceans are literally freezing up, or they evaporating, because I think we've lost our atmosphere as well. Life likelihood is at 0%. So definitely nobody's surviving after 185 years. Let me pause that just for a second. I don't know if you can see it the way I'm seeing it, but this looks like our moon, just without the craters. It looks like a massive snowball at the moment. Earth similarity is at 26%. So yes, it's probably still the same size. However, if you have a closer look, it just looks like our moon, barren, just crater-ridden. Nobody would survive such an impact. That's obvious. But let's go even further into the future. Now we're at 7,000 years into the future. I don't know what about you guys, but 5,000 years in a cosmic scale, I still consider it a very short time. Now, if we have a look at the composition of Earth, still the same mass, still the same radius, similar density. But if we look at the surface, average temperature is minus 260 degrees Celsius. That is, I think, just as cold as outer space. So we definitely lost all the heat, we definitely lost all the atmosphere, and now we are just becoming a barren land, very similar to Mercury, Moon, or even Mars for that matter. And there is no possibility for life at all. Now, if you ask me if such an event was to happen, I'm not saying it ever will, because as some of you may know, the moon is actually moving away from the Earth, slowly but surely. But if it was to happen, I think this is the end of the world. Point blank. There is a lot of scenarios that could end our planet for sure. However, this one is closer to home than anything else. So there you guys have it. If Moon struck the planet, nothing and no one would survive it. There is not even 0.1% chance for that to happen. But now we are done with this one. Let me open up another sim for you. So, this simulation, this is our solar system. Let me just start it and slow it down just ever so slightly. And our focus is Jupiter. As you can see, we've got our local gas giant traveling with all of his moons. What a beautiful symphony and symmetry. Of course, this is just a simulation, but what I'm trying to do is to get Jupiter to become a star. Because I've heard a fantastic theory, which I would love to do a film on. That theory says that Jupiter is actually a failed star. Because of its size and because it's a gas giant, a lot of scientists speculate that this could be a failed star within our own solar system. So if that was true, that means that we could have been very close to having a dual sun or two-star system. Yeah, it would be a game over. Of course it would be. Of course it would be. Hello, prankster. Right. So in order to turn Jupiter into a star, let me just slow this down a little bit so we can have a better look. There we go. We need to increase its mass. Now, currently, it's just a mass of one Jupiter, which that's exactly what it's supposed to be. However, if we change it to one solar mass, there you have it. Did you see what just happened? Mars has burst into some form of sparks and flames. You can see all these fiery fragments turned into asteroids, and Jupiter is now a star. But you might think, hold on, why is it a dark star? Why isn't it shining the way it's supposed to? Well, we can look at the composition, and it just doesn't have enough mass nor energy to start shining brightly. But we can change that. We can definitely change that. We need to add some helium. So let's quadruple what it currently had. And it's starting to glow. You see, those processes that govern our sun are just currently starting to govern Jupiter. Now, because Jupiter is now much bigger, all the orbits of its moons have been disrupted. But it's still not a full-blown sun just yet. Let's double its surface temperature. So now you can see it's getting hotter and hotter. Let's double its luminosity so we know we can see it shining a little bit better. Let me just quadruple its surface temperature. Let's quadruple the amount of hydrogen and quadruple the amount of helium. Increase it in size. Decrease all the water. Lower the iron. No. Okay. Bit things a bit. What's going to happen to the orbits? Because now Jupiter has a lot more mass than it had previously. It started to pull our whole solar system towards it, and it's still not a full-blown star. Let's add 10% luminosity and 10% temperature. And as you can see, Jupiter has turned our whole solar system into a spectacular show of a supernova. What a sight to behold. However, what really is baffling me in this particular scenario is what happened to the sun? Did the sun go supernova because of the mass and the size of Jupiter? I don't think the supernova would be this big if it did. However, I might be wrong. How far can we push it? Let's see. How far can we push it? Now, it has 399 masses of the sun. So it's 400 times more massive than our sun. Let's push it to the limit. And now Jupiter has turned into a black hole, which is sucking up, pause, our whole solar system. Even the Tesla Roadster. Oh no, Tesla Roadster is actually getting pulled away. It's running away from Jupiter. James Webb Space Telescope is there as well. And this is Jupiter as a black hole. So, yes, we could potentially turn Jupiter into another sun. But that would be another catastrophe for the whole solar system, not just for our planet, because I think our planet disappeared the moment we made Jupiter bigger. But now that it's a black hole, our whole solar system is gone, with the exception of James Webb Space Telescope, which can't transmit data because there's nobody else to see it, and Tesla Roadster. I've heard a lot of great stories about Teslas, so they can even survive black holes? I don't know. I don't know. Well done, Elon. What's next on the agenda? Right. So, let me bring back the simulation of our solar system. Instead of focusing on Jupiter, we'll now focus on our sun. So, let's slow things down a little bit. What would happen if we replaced our sun with a black hole? there is a lot of answers to that specific questions and a lot of variables, like how big is the black hole, and also in which point do we put the black hole. But if we put it exactly where the sun is and make the black hole exactly the mass of one sun, what do you guys think would happen? Do you think everything will get sucked in? Will we continue to orbit? We're going to see what happens to Earth in that specific scenario. But let's just replace the sun with a black hole that has one solar mass. There we go. Let's speed things up a little bit. And let's focus on Earth. Let's see what is going on. We are still orbiting. Nothing has changed in terms of the orbit. I don't think anything is getting pulled in more than it was before. However, if we look at Earth, there is a lot that has changed since we changed our sun for a black hole. Now, the first thing that you might notice is the average temperature dropping to minus 56, 58, 60. It's constantly dropping. So now we even called it in Siberia. And that's the average temperature of the whole planet. The minimum temperature is minus 38 and still dropping. We are about 3 years since we've replaced the sun with a black hole. I'm surprised to see that no orbit has been significantly changed or getting sucked in just because it is a black hole. Okay. The Earth is getting colder, however it is kind of stable now. Let's see the composition. Life likelihood, surprisingly, at over 75%. Now that is a lot. You know, that tells me that, yes, majority of the humanity will probably perish. But there will be a lot of life still on the planet. Perhaps subsurface, deep underground where it's warmer because of Earth's core. At least that's my speculation. Okay, but let's mix things up. So now we've got this black hole, which is at one solar mass. What if we were to just double it? Here we go. Now we can see major changes in the orbits, especially amongst the closest planets. Let's see. Jupiter still seems unaffected, although it does get sucked in a little bit more. Now, Earth is steadily going. Average temperature, surprising. Average temperature has risen by at least 70 to 80 degrees, but it's dropping now till about 35, and we are about 16 years since we've replaced the sun with a black hole. So the temperature has risen to about 20 degrees Celsius, and now it's dropping, as you can see, but we've got a steady temperature of minus 67 degrees and dropping. Is there any chance for life now? Life likelihood, 0%. So if we replace the sun with a black hole that was twice the mass of the sun, within 15 years of that happening, there will be no life on the planet. And as you can see, all the orbits again pulled in, even Uranus, as you can see, it's coming very, very close. Jupiter is now where Earth once resided. This is crazy. Such a force. Okay. What if we make it even bigger? Let's make it 4 solar masses. The whole solar system has now came closer than Mars's orbit. This is extremely close. Let's slow things down for a little minute because I'm getting motion sickness. Let's look at Earth. What is the average temperature now? Very stable. Minus 125 degrees Celsius. Obviously, there is 0% for life, so I'm not even going to go and check. We have no atmosphere, no surface pressure, no atmosphere density. The black hole has sucked all the life out of Earth in a matter of 20 odd years. So as you can see, that the process is not instant. It's not something that happens instantaneously. It will still take some time. And if you were on the planet when our sun would be replaced by a black hole, and if you are the unlucky survivor, you will literally get to see the whole planet turn into a barren land in front of your own eyes. And that is a very scary thought. But let's go crazy, shall we? I'm going to turn this black hole into 40 solar masses. Whoa. What is happening here? Mercury and Venus officially ceased to exist. Their particles are being flung around. Smaller moons again attracted as well, ripped into shreds. Earth has now very small elliptical orbit. And it's getting turned into cosmic debris full of molten rock, lava, and now Earth is just classified as a satellite orbiting a black hole. It's not even considered a planet. Look at all those fragments of our beloved planet just floating away into space. However, surprisingly, Parker's solar probe is still orbiting like nothing has happened. Although its orbit is very small, so maybe, no, look, it's still orbiting. So it's not like a black hole is this monster that just devours everything. You can clearly have objects, even man-made ones, that can orbit it quite safely, I would say. Interesting. Well, let's make this black hole even bigger. 400 solar masses. Now, Parker's solar probe is just getting annihilated. Slow this down even more. Let's look at Earth. What is the temperature like? The temperature on Earth at the moment is 2200 degrees Celsius. That is extremely hot. But I would have thought, since it's a black hole, we would be colder like we were when it was just much smaller, so to say. But clearly, Earth has turned into another Venus on steroids because of what we did here. Let's zoom out a little bit. Interesting. Jupiter is on a very close orbit around the black hole. If we look towards Saturn, Saturn is still quite far away, much further than I would have expected it to. But let's follow Saturn and speed things up. Oh my god, all these objects are just getting torn apart and flung into orbits with all this gravitational pull. What's going to happen to Saturn when it gets closer? Slow this down. Saturn has been thrown back with such a force. Saturn now on fire. Tighten Saturn. And Saturn got quite hot as well. Although I was expecting a lot more devastation. Let's go crazy. Let's make it 4,000 solar masses. Now that is a big black hole. Although it's still keeping a lot of celestial bodies in our solar system in, I don't want to say intact, but definitely in better shape than I would have imagined. Make it much. Make it 3 solar radiuses. Now we're talking. Now, nothing is surviving this black hole. Yep. We've got our latecomers, Pluto and Neptune. Speed things up. Nothing has remained of our solar system. There are some fragments which have been flung out in the early stages, but everything within the radius of our solar system, it's officially gone. That is crazy. Not going to lie. So what's agenda? Do you guys want to see something in particular? Please drop me suggestions in the chat, and we can certainly try and make this happen. Now let's go back into our solar system. Up next, I want to see what will happen if we place a second sun as close as Mercury is. So let's delete Mercury. Let's add another sun. Oh, sun. Placing another sun here. We're near 2026, so we are in the future. Let me slow things down a little bit. And there we go. What is going to happen? Oh, Earth has been destroyed fairly quickly. So all this debris, all the fragments that you can see, this is our Earth. It's no longer in existence, so I can't even tell you what happens. However, looking at the grand scheme of things, anything up to Jupiter's orbit seems affected. Our two suns are in a celestial dance. They are just spiraling around each other. As you can see, there is, I guess that's plasma being ejected from either one of the suns as they come close together. And they are slowly drifting away from the center of our solar system, but they don't necessarily pull everything with them. Now, I was under the impression that if we had a second sun, such a massive gravitational force, that would kind of work like a bigger black hole or a bigger body of mass, so to say. I'm very surprised at the moment. Let's speed things up. Let's see what happens in a matter of months and years. So the suns are just dancing together. Tesla Roadster is very closely following the suns. Jupiter is following the sun as well. Although it seems like the sun is moving way faster than the rest of the orbits. That is very surprising. But nevertheless, the outer solar system, anything past Saturn, does not look like it's even following our dual sun. Our two suns are just drifting away into the Milky Way. James Webb Space Telescope has completely lost orbit. It's just drifting into outer space. Parker Solar Probe completely off course. The only thing that is closely following two suns is, surprisingly, Tesla Roadster. That is very interesting. It even looped around. I'm very surprised by that. Because I was expecting the whole solar system to just follow into the path of two suns, but that doesn't seem to be the case. Okay. Completely not what I expected. But now the question arises, will the same thing happen if instead of placing a second sun, I will place a black hole at the orbit of Mercury? Okay, let's do this. So we delete Mercury again. We don't need. Let's add a black hole of one solar mass where Mercury used to be. Slow things down. Okay. Similar dances happening. I guess that's because the black hole is exactly the same mass as the sun was. But we can always change that. However, yes, exactly the same thing happens to the orbits as it was happening before. But let's change things up. Let's turn up the density of the black hole. Let's turn up its mass. So the dance is now a lot quicker. But the sun isn't getting sucked in. But the black hole should be sucking the sun in because of its mass. Did I do something wrong? Yeah, it's twice the size of the sun. Okay. It has way higher density. let's make it even more interesting. Now it's 5 solar masses, and it's still not sucking our sun in. And majority of the solar system isn't following either. Again, that is very, very surprising, because that is absolutely not what I would expect to happen if a black hole was in our neighborhood. Okay. Oh, we made its radius 149 kilometers, and our sun got sucked in immediately, within a space of a day. And because the black hole is so big, now the rest of the planets are following, and our Earth, as you can see, it's a cold, barren land, and it's now turned into a hot, barren land as soon as it touched a black hole in its orbit. There is absolutely no possibility. Let me just see. Yeah, 0% of life. All the planets are slowly following, although Venus was one of the closest objects, because remember, we deleted Mercury. Now Venus is just slowly drifting away from the black hole. So is Vesta, so is Saturn, Uranus. They just look like they kind of stopped in their orbits, right? Because if we speed things up massively, look what's happening. Now Saturn is following with absolutely disastrous orbit. Everything is just spinning so fast. Slow things down, and you can see that the closest object to the black hole is now Mars and Venus, Jupiter with all of its moons. Look at that beautiful spiral. Everything now is going in a very narrow, straight line, and everything is just orbiting so closely. But what is truly amazing to me is the fact that despite black hole being so big and so powerful, majority of our solar system is still intact. I was expecting a lot more disappearances, if you catch my drift. That's interesting. Okay. And what's the situation like on Venus? Okay. Temperatures are not too far off from what they currently are. Isn't that beautiful? We were here with our sun, and now everything is spiraling out of control, with our black hole just dragging the whole solar system with it. Except for some comets, some asteroids, satellites, fragments, nothing really significant. How long will it take for all the things to get sucked into the black hole? Let's just speed things up. For this chaos. And off we go into the void. I wonder if such an event would take place. Would that black hole drag us out of the Milky Way? Or will we still stay within the grasp of Milky Way's gravity? Because bear in mind, Sagittarius A, the black hole that is in the center of our Milky Way, is way bigger than this. As a matter of fact, let me just show you how big the Sagittarius A star actually is in comparison to our solar system. So we are in our solar system again. Now let's turn the Sun into Sagittarius A star, which again is a black hole at the center of our Milky Way. See the difference? Everything is paused, but you can already see Mercury, Venus, most likely everything up until Mars is going to get sucked in immediately. And then we'll see what happens after. And this is just 10 days a second. So we haven't even crossed the threshold of 1 year since the event. And nothing, absolutely nothing, except for Voyager 1 and 2, has survived such an exchange. If we speed up the time, both of them will disappear in less than a year. That's the power of Sagittarius A star. This lies at the center of our Milky Way, holding the Milky Way, the whole galaxy together. Truly, truly amazing. Anything else you would like to see? This simulator is very, very versatile. There is many things we can explore. Just drop your suggestions in the chat, and I'll try and entertain whatever suggestions you might have. Let's see what simulations we have in here. How about we'll see what would be the life likelihood in our current solar system if Earth was a super Earth. So currently, minimum temperature on the planet is minus 59.2 degrees Celsius. Maximum temperature is 16.4. Average temperature is 7.24. But we are still the same size as we were. Right? Slow things down a little bit. Okay. Everything is nice and slow. Now let's see if we've turned Earth, what would we say, twice the size? Let's see what's going to happen when we only have twice the size. Speed things up a little bit. So Earth is actually losing quite a lot of material. I don't know whether that's because the moon is getting sucked in, or maybe it's because Earth is now much bigger and the Earth has and the sun has a lot more effect on it. But let's see. The minimum temperature has dropped massively. Now at minus 89 degrees Celsius. Max temperature is very similar to what it was. I guess that's because of the season that we are in our current rotational period. This cloud of debris and material is very worrying, because I don't know where it's coming from. I think it's coming from Earth. This cloud of just cosmic dust. The orbit seems unchanged, which is, I guess it's a good thing. See at the composition. So it's 8 times the mass of current Earth, but only twice the radius. Life likelihood is at 26%. That is interesting because it dropped by 74%. And I'm just wondering why exactly has that happened. Let's speed things more. Let's go around the sun a couple of times. The temperatures are stable, I would say. We've lost a lot of water. Also, because if we look closer on the lit side, there is a lot of bodies of water showing up inland. Okay. Sahara now also has massive lakes or small seas. Right. Turn things up a little bit. Let's make the Earth 4 times the Earth's radius. And now it's at 0.2 mass of the Jupiter. Did you see what just happened? Was that our moon? I think it was. So if we make Earth 4 times bigger than it is currently, we now know our moon is due for impact. And I think any chances for life that we had, I think we've just lost them. Life likelihood is at 0.00115%. Okay, speed things up. Let's see what happens. Will it improve? As you can see, years into the future, it's improving ever so slightly, but not improving enough to have an impact. It will take thousands, if not millions of years to bring it into 26% again. But now Earth is massive. But I don't see anything disrupted other than our moon disappearing. Let's once again see what are the temperatures. So the average temperature 166 degrees Celsius. That's exactly how it feels in the UK today. So I don't think we are that far off. Composition. We are at fractions of a percent in terms of life likelihood. So I don't think we ever getting that back. And now Earth looks just like a barren wasteland. No significant features. You can't see continents. Everything is just wiped from that impact. I think there was a lot less devastation when Earth was smaller and Moon hit it, but that's just my observation. So now we are 26 years into the future, about 20 years since the impact, and still Earth looks worse than Mercury. You can't even see a crater. It just looks like a polished, smooth wasteland. That's the only way I can describe it. But either way, it's been a pleasure having all of you that were watching here with me, and anybody who will be watching this after the live. Make sure to subscribe, leave a like. A new video is dropping tomorrow, and that's all from me. Thank you for watching. Keep looking up.